Hi, Mr. Long. This is Hanson Lee doing the AP Physics FRQ 3. Start. So A is asking for the free body diagram. So this is going to be the normal force or the contact force because it's on a surface. It's going to be the force of gravity. There's going to be the applied force going horizontally. And there's going to be the force of friction because going down the slope because the block will be going up. B is asking for the contact force. So let me just draw the diagram out. It might be a little small, but here's the normal force. Here's the force of gravity and its components. Here's the force of friction. Here's the applied force and its components as well. So the forces acting in the y direction is what we're going to be using. So the only forces acting in the y direction is going to be Fn, the contact force or the normal force, which is what we're looking for, minus the applied force in the y direction, which is going the opposite way, and Fgy, which is also going the opposite way, so subtraction. This will be 0 because the block is not going up or down in the y direction, but just going up the plane. So we can move these over. So Fn equals Fy plus Fgy. So we can turn that into its parts. So Fn, the normal force or the contact force, is going to be equal to F sine theta plus mg cosine theta. Yeah. Okay, C. Can you see that? Yeah, C. For the block's acceleration. So there's going to be Fx, applied force in the x direction, minus Fgx minus Fk equals max. So this is going to become F cosine theta minus, and Fgx is going to become mg sine theta minus Fk is going to be the same as mu Fn, and we just solve for Fn. So mu times F sine theta plus mg cosine theta equals max. So F cosine theta minus mg sine theta, we're going to distribute the negative or the minus mu. So minus mu F sine theta minus mu mg cosine theta. Let's just do another step really quick. Since we're going to isolate for a, we're going to divide by the m. So this is all going to be divided by m, and the m would cancel on the other side. So a equals all of this, f cosine theta minus mg sine theta minus mu f sine theta minus mu mg cosine theta over m. All of that is the acceleration of the plane. Okay. D is asking for the force that will allow the block to have constant velocity up the plane. So that means that A is 0. So if A is 0 and we're trying to solve for F, we would have to move m over, so times m. So this would just become 0 equals all of this. So let's just save this a step. Sorry, I have to keep looking back at it. So there's no m on the bottom because it would just be multiplied times 0 and become 0 already. So we're going to try to find f, so we'd have to keep the terms with f on one side and keep the other things without f on the other side. So plus mg sine theta plus mu cosine theta. So f cosine theta minus mu f sine theta equals mg sine theta plus mu mg cosine theta. So we can factor out the f. Cosine theta minus mu sine theta equals mg sine theta plus mu mg cosine theta. So we're going to divide this by cosine theta minus mu to isolate for the f. I about all this, and then sorry, I'm just trying to hurry up. F equals mg sine theta plus mu mg cosine theta divided by cosine theta minus mu sine theta. Part D is also asking for the relationship between mu and theta. Since you can see this is a fraction, we don't want the answer to be 0 because you can't divide by 0, and we don't want it to be negative because that would make f negative, and it's not, because it's moving to in that direction and to right. So what this means mathematically is cosine theta minus mu sine theta is going to be greater than 0. So move over mu sine theta. So cosine theta is greater than mu sine theta, and divide by sine theta. So this will give us the relationship that cotangent theta has to be greater than mu. E. So it's just going to be plugging all the numbers in. So the mass is 2 and acceleration is going to be 0.5. So let's just turn that into 1. 0.5 times 2 is just going to be 1 equals, this is going to be a lot. Let me just pause it to write it down. I know it's kind of hard to see, but that's what we get. I'm just going to turn it into numbers to make it easier, but leave the f terms because we're going to factor out for f and then find the f again. So I'll be right back. So the top one is going to be for this term and the bottom one is going to be for that term. So that's what I got if you were to do the math. So 1 equals f cosine 20 minus 6.7 minus 0.33 f sine 20. We can't solve for that yet, because we're going to do something else to that, minus 6.08. So what we're going to do is move over the 6.7 and the 6.08. So, I know I don't need to do this with a calculator, but we get 13.78 equals f cosine 20 minus 0.33 f sine 20. So we're going to factor out the f to get cosine 20 minus 0.33 sine 20 equals 13.78. So let me do the thing on the calculator. So the thing in the parentheses is going to be this bottom number, which is like 0.83. So 0.83 cancels all of this out. And we have to do it on both sides. So 13.78 divided by 0.83. So the force is going to be 16.6. Newtons. Yeah. It doesn't say magnitude, so I'm just gonna say horizontally to the right. You can say positive. F. Be doing it right here. So let me just mark this space out. F. This is gonna be an additional mass 4m. So to keep the system motionless, that means V equals 0 the whole time. I think that's just going to be A equals 0, because that's the only way you can have a constant velocity of 0, not changing at all. So I'm just going to set it to 0. Yeah. So I'm going to be treating the block, like the two blocks, as one, so 5m, if that makes sense. So it's just going to be the same equation. As the one we did it for C. I mean, no, part D. So it's going to be this, but A is going to be 0. So F cosine theta minus, remember this is going to be 5 mg sine theta minus mu times the Fn, which would be F sine theta. F isn't being affected, but plus 5 mg cosine theta equals 0. So we're gonna move. Okay, I'm just gonna do that later. Let me distribute mu first. So sum mu equals 0. So we're gonna move every term that does not have an f over. I'm just gonna pause it and then unpause it because it's taking a long time. So this is what we get. Let's factor out f equals this being brought down. I'm not gonna waste your time. And we're gonna divide by cosine theta minus mu sine theta on both sides. So the force to keep the system motionless is gonna be 5 mg sine theta plus mu mg cosine theta all over cosine theta minus mu sine theta. You can take out the 5 if you want. I don't know why I did that. But yeah. So you should get 5 times parentheses mg sine theta plus mu mg cosine theta over cosine theta minus mu sine theta. This video is becoming really long. G. I think I'm just gonna flip the paper over. G is just plugging in the same things with the old formula, so I'm just gonna pause. I don't want to waste a lot of time. So what I did was take the formula we used in C, because it's just basically the same thing, but we're gonna change the mass because this time we're using, like, we're combining the blocks into a 5 mass. So this is gonna become f cosine theta minus 5mg sine theta minus mu f sine theta minus mu 5mg cosine theta equals 5ma. So that's 5 times the mass because we combine the blocks. Basically I'm gonna have to plug all of these numbers in, so let me pause it again just to save time. So this is what we get when we plug in all of the givens. So 2 times 0.5 is just 1, so this is going to be equal to 1. Let's solve for the ones that do not have an f, because we're going to try to find f, and we're going to have to isolate for it. So I'll put the other these terms into the calculator and come back to you. So with this number, the second from the last one is going to be this, and the last one is going to be this whole term. So this is going to become, we're actually going to move these over, so let's just do that. This is basically 33.5, so these cancel out because we just solved for it. This will become 30.4, so these cancel out. And we're just going to move that all to the right side by doing that. So 5 times 1 is 5, yeah. So this would become f cosine 20 minus 0.33 f sine 20 equals 5 plus 33.5 plus 30.4. Isolate for f. Cosine 20 minus 0.33 sine 20 equals, I'll put on my calculator. I'm at least solve for this one too. I got 0.83 for this one just to save some time. So this is going to be 68.9 over 0.83. So F equals 83 newtons. Right. Positive if you want to, because it doesn't say magnitude. Now I have to calculate the magnitude of contact force. So we're just gonna look at the second block, 4m, because I don't want to deal with the applied force. So the forces acting on 4m is gonna be F, m on 4m, the contact force. Then there's also going to be F G X 4m minus F K 4m equals M A X. Sorry, this video is a bit long. So I'm assuming that we're going to use the same givens as G, so this is going to become No, this is going to become 8. Since we're looking at 4m, this is going to become 8 because 4 times 2 is 8. And this is going to become 0.5. So it's just going to become 4 later on. So we're going to have to move these over. So we're going to add fgx4m to the other side, fk4m. So this is going to become fm4m, the contact force, equals 4 plus fgx4m plus fk4m. This is going to be 4 plus 4 mg sine theta plus mu times 4 mg cosine theta, and I'll be right back to you with these plugged in. So we get 4 plus 26.8 plus 24.3. So F is going to be 55.1 newtons, the contact force between M and 4M. Okay, I'm not running out of time. Sorry, this video is so long. So if you switch the order of the blocks, this will change the. Let me just show you. So we're basically gonna look at the second block, but this time it's just gonna be M. So M on 4M minus FGXM minus FKM equals MA. So this would move all these over. This would become F equals, this is the same as mg sine theta plus this is the same as mu mg cosine theta and plus max. So all of these are being affected. These are no longer 4m, but instead are just m. So disagree, because when you're looking at the second block, the mass will change and affect everything, all of the terms. So disagree.